Hello world! So today I thought I'd go over some of my thoughts about how to secure microservices and other service designs that you may be building inside your organizations. So let's just jump right into it. Here are a lot of the problems people have in a microservices or services world, right? The first of them is kind of self-explanatory, poor RBAC, role-based access controls. And you'll hear this as a complaint of, oh gosh, we have all these over-provisioned users, and if one of them gets compromised, they have access to everything, right? Another common problem is missing telemetry. If you have a service and it doesn't record anything at all, then your security team is going to have a really hard time figuring out what happened in a hack. You may not even know that you are hacked for a long period of time. Uh, Another huge problem is that there's so many different AAA systems: authentication, auditing, accounting technically, and authorization. So when you have a lot of sources of truth, when there's so many of them, and you have a service that's designed, you may end up in a situation where you don't even know who has access because you don't know where to look. Some parts of the service authenticate or authorize against LDAP, others are using OpenID, others are using a internal DB built for the service, and it gets really hard to know who's got what access privileges. And escalation of privilege is one of the most common attacks that you have in the world of security on services. Another huge problem is, well, false positives. You don't want to be in alert hell. If every time someone logs in, your security operations center or your operations person get an alert saying, hey, someone logged in, well, that's going to burn them out really fast and they're just not going to care about their alerts, right? A lot of companies use firewalls, and they're a great idea, right? But the problem is once someone gets behind a firewall, and if you have a large number of employees, there is an attacker or a hacker behind your firewalls, then a lot of services don't have any authentication or authorization in place at all. So anyone can just connect and start dumping data. A huge problem are what happens to services as they become older, right? Maybe your marketing team hired a vendor to write a service for you, and you guys were a massive success, and it became a huge billion-dollar thing. And now it has no AAA, it has no telemetry, you have no way of knowing what's going on with it. Seems to be well secured, but you just don't know, right? And that becomes really hard because you can't go back and change the code. How do you kind of fix that? And proxies are a good way to do that. A huge problem is just unsecured data. Combined with the poor RBAC and with no encryption policies, you could end up with data that's literally just on a file share or on an Open Connect database or relatively close to Open Connect database with, basically everyone in the company has access, and then a hacker just has to compromise anyone to gain access. One of the interesting problems I've seen is the blocking self problem. This is where you try to remediate an attack and contain it, and you black hole an IP or something like that, and all of a sudden you've black holed your own services and you can't respond to anything yourself. So that can be fixed by maintaining critical service lists and critical server kind of lists. ServiceNow has a good product for something like that. And then possibly the biggest problem isn't that you respond well during a breach or security incident, it's that any improvement investigations are really slow. This is usually a feature of the RBAC being a little bit too broad for security personnel. Although RBAC is great for preventing the wrong employees from access to resources they shouldn't, you have to make sure that the right employees do have access to the things that they need. So coming up with all these problems, I've kind of devised this little flow chart here of how we can go through and solve them. And this is sort of my definition of what I call a service design framework, right? So let's start off with that. We'll start way off in the ideation phase. That's what the little light bulb over here is for, is this is an idea, right? Oops, let me put that into pen mode, right? And some of the requirements that you should think through when building a service is, you should have your RBAC requirements. And you should think about your employees and groups of employees as one of the series of roles you'll need to define. Not just one role for all of them, but maybe a handful, right? Security personnel, for example, should have access to see any log or any security incident event management information anywhere or any database, but your receptionist probably shouldn't have that level of access. You should also have this concept of an admin user and an admin user interface. And those admin users and user interfaces should be separately secured through something like CyberArk or another technology. This way, if someone does get access to the actual back end of your firewall, they have one more layer they have to clear to get access to the admin user interface. And then you have to think about all your other RBACs, right? I've got users, and users are allowed to see X data themselves, or about they can be delegated to see information for their organization, or things like that, right? And these are just things you have to define during the idea itself, right? You also need to define your AAA, your authentication, authorization, and technically accounting, but I'm going to use auditing. And you should define this policy on a per user, per device, and per network basis, right? You might want to say something like, hey, when Jim is on his iPad in the office, we're going to require less authentication information than when Jim is on a Windows PC in a coffee shop in China, right? So you might want to institute additional challenges or additional multi-factor authentications or things like that when these things change up. You have to have a requirement that there is telemetry, right? And there should be some sort of standard. One thing that should be in your standard is some sort of session ID, even for anonymous users. This way, you have a way to track what records were accessed by any service by which users, right? Even if they're internal and behind a firewall. You also have to have a way to update the telemetry, the information that you send back and forth, outside of updating the service itself, right? So maybe you've got a proxy in place and you update the proxy, or maybe you've got a separate library that's called in and called out, right? Then there's going to be policies you'll have to define for yourself. You're going to have your own update policy for the service itself, and then you're going to have your data access policies, right? HBI, high business impact information, must be encrypted and stored with AES 192 or better, and must transit with TLS 1.2 or better, right? That might be a good way to define that. Your security team should have keys to the kingdom. They should be able to see anything, but maybe not they should be able to change anything, right? And then, of course, your encryption standards. What are you going to do with medium business impact or low business impact data, right? So that's just beginning the idea phase. All right, so now that we've talked about the idea phase itself, let's go a little bit further and go to the design phase here, right? So I'll use a different color because, I can. It seems like fun. And so in the design phase, well, that didn't really work out so well, but it's all right. There are a handful of things we want to do in the design phase to make the design of the service itself more secure or more easy to secure in the future, right? Threat models are in here twice in design and build, and I really mean them that way. There are two different threat modeling frameworks I really like. Dread I like at design phase, and Stride I like during build phase. I tend to use Dread for t-shirt sizing, right? This risk, discoverability of our service is a Dread risk, and it's high for this particular service, right? Whereas other services may be entirely back-end and sandwiched between other services, in which case your discoverability tends to be a lot lower. So you could maybe make that a medium or a small. And then pick ahead of time which t-shirt sizes you're going to address in either creating telemetry for, test cases for, or some sort of mitigations plan against that risk, right? Now, telemetry, the reason I put telemetry into design phase and not into the idea phase is here's where you actually go into the nuts and bolts of what you should send. And that is going to be really dependent upon the service or microservice that you're building. And I'm breaking telemetry into two different types of telemetry, functional and trace logs, and they differ in what they are and how you want to deal with them, right? Functional telemetry is digested telemetry. It's telemetry that states that a scenario has happened, right? Whereas tracelog telemetry is literally, I have called into this function, and here are the parameters within the function call, and here's the return from the function call. Tracelogs are really expensive telemetry. Because they are expensive, you're going to want to have a way to turn them off. And you'll only turn them on in selected instances. For example, when you're sampling, or for example, when you're doing an investigation of some sort, right? Whereas functional telemetry should be sent all the time. Now, once you have these two different types of telemetry, functional and trace logs, right, you have to think about how they're going to actually be sent and stored, right? You're going to have some sort of processing pipeline, and you're going to have some sort of storage system, whether you're going to store in SQL or you're going to use Hadoop or whatever. It doesn't really matter to me. But what matters to me is that you separate out what's real time versus information that's not used in real time. The rule of thumb is if a security personnel, an operations center worker, needs this information to do an alert, then that is real-time information. If this is used by the business for other things, such as how many users did we have today, pirate metrics, then that's analytics information. Real-time information is actually a lot more critical and should have its own separate pipeline of processing, and it should be available quickly and stored for shorter periods of time. Let's say 2 hours, right? Most analytics processing pipelines usually kick in at around 2 hours of time. And so what you can do is you can duplicate the data between real time and analytics, and you can drop it in 2 hours for real time, but keep it for as long as you want, whatever your data retention policy is going to be during analytics usage. When you do sampling in your data transit pipeline for your telemetry, then you want to have two separate mechanisms of controlling the sample. One, you want to have a send sample knob, I'll call it, right? Which lets you say that my client or backend service is only going to send this trace log 1 out of 1,000,000 times, right? And then you want to have processing telemetry, processing sampling that can say, I'm going to only accept the telemetry sent 1 out of 100,000 times or something like that. The reason for this is if you don't have a separate client sample and a separate processing queue sample, then you'll completely saturate your processing queue instantly with trace log information, right? And so now you've got this problem that you can't really look at anything because you're getting too much information to actually sort through in any practical system. So that's why you need to be able to sample on the client itself before it's sent. And then processing queues, they're going to have variance in use, right? In one day, you might discover that you have a lot of users, and another day, you may discover you have none. There's seasonality in how people use your product, even if it's a locally installed product. And because there is this seasonality, weekends or whatever, then you might discover that on high demand times, you may actually have to sample the processing queue itself in order to get enough useful information for your systems to remain real-time functional. All right. And then last but not least is, by design, you're going to have these APIs. I'm presuming that you're using REST API design, but you may not. And one of the interesting problems I've seen in REST API design specifically is proxy forwards, right? So you've got this service that's sandwiched in between two different services. I'm going to just draw it out over here, right? And I'm actually going to try and make the blue, right? So let's imagine this box here is service A. And let's imagine this box here is service B. And let's imagine this box here is service C, right? Well, the problem is that service B's direct caller is A, but it's actually calling on behalf of it's acting as a proxy for some user. Could be an admin user, could be a direct web user, it could be a user of your downloaded product, right? And it's not very useful telemetry to say that A called me, and that's my user, because now you have no way of disambiguating who the actual caller was. That's the reason why we have the session ID over here, right? The session ID is, even if you don't know even if B doesn't know who the caller of A is, as long as the session ID is passed on to B, then that can be correlated back inside your SIEM, your Security Incident Event Manager, right? So that's something that should be really importantly it's really important to track your proxies, right? You'll have a lot of X forwarded for or forwarded headers as well that you can use. Another thing that you have to really be concerned about in your APIs is overhydration, right? Let's say you've got an API for doing something like an address change. Well, that address change API should not also return information about the user's credit card. And a lot of times what happens is all this information stored in the same database, and it's easy to get because you have to query it, and so the microservice in this case will simply return everything back. Now, you may need to patch hydration in the future too, and again, that's where API proxies can be really useful. And the final thing that you should really think about in API design is don't make a lot of different AAA calls. Don't say I'm going to authenticate against OpenID for, function 1, and I'm going to authenticate against LDAP for function 2. When you span multiple sources of truth, you just create this problem for yourself of figuring out which source of truth is currently being used. And, a developer can do it with the debugger in a debug version, but in a real security incident, it may get really hard to know who the attacker even was. So that's it for my thoughts on the design phase. So let's talk about the build phase. The build phase is the bulk of your V1, and I guess it's the bulk of your coding time, right? Most of the time that you spend coding is actually in build time. However, I've put probably the least number of things in the build phase. For the most part, you're designing your functional product here. The important thing for future consideration in operations is going to be this is the time that while you're building your functions, you should be doing your functional level threat model. The tool that I like to use, or the framework I like to use for functional level threat models is Stride. And the way I like to use it is, I just do the S, the T, the R, the ID, and the E across on my horizontal axis on an Excel sheet. And then for each function call, I score it. So let's say the spoofing risk for function foo is a 10. Right? And let's say the tampering risk is, an 8. Let's say the repudiation risk is like a 7, and so on and so forth, right? Then I add function foo's calls, the 10, 7, the 8 across, and I get a score. And then I pick a threshold ahead of time that says if the score should ever exceed the total score for this function, right, the stride added together, then I'm going to do some additional work. I'm going to send additional telemetry, functional telemetry in this case. I'm going to write test cases, and I'm just going to spend more time thinking about how this function can be protected or remediated in the future, right? Since you're writing code and building your functions, this is a good time to use a framework like test-driven design. You're going to have bugs, and it's unavoidable. No one writes perfect code. We're only human. And even if you had some sort of perfect machine, I'm sure it would make imperfect mistakes, even though the machine itself is perfect. I'll talk about that later. Actually, I won't, but it's a philosophy thing. So anyway, going back to TDD, TDD can help you foresee bugs, right? And it can help you prevent what you can foresee. So the last thing you want to do in a security context is also deal with technical debt, right? Many organizations have technical debt and security debt, and you really want to be minimizing both to have the smallest footprint possible for attackers to attack you on. Anyway, that's more of an aside, I feel. But anyway, going back to telemetry, which is really the bulk of what we're caring about in this case, is now that you've got early builds of your product, you're able to start seeing what's being sent. And you're beginning to start building out your sampling pipelines, your processing pipelines, and you're able to start seeing what kind of storage you actually need. Think about small data first, then big data, right? And that's a really interesting storage capacity kind of argument, right? Your real-time telemetry should be thought of as first, and it should be as little data as you can manage to send. In order to make real-time work, it has to be small. You cannot process a terabyte or 2 of data per hour in any meaningful capacity. That's what your analytics pipeline is for. So think about your real-time and shrink it to the bare minimum you can think about given your scenarios, right? And then think about your analytics. Can you build your analytics from trace logs? is a sample of, 0.001% of your users with full tracelog information, enough to give you your analytics pipeline as well. That might be a good way to go. And a lot of times the answer to that is yes, although it does require a higher level developer in order to build an analytics pipeline from such a granular data source as a tracelog. Right? So that's where we're gonna kind of focus on in the build phase. Now, one of the we'll move on to the deploy phase here, and I'll pick a different color, green, because, why not? So, deployment might be where your organizational maturity really shows up, right? I believe that there's essentially 3 levels of security maturity possible in an organization. There's level 0, which is nothing, and frankly is probably 80% of all services out there, right? There's level 1, which is response capability. And there's level 2, continuous improvement. I'm terrible at writing, but hopefully you get the idea that this is continuous improvement. Now, the separator between these 3 layers really seems to be this first idea here, quality gates, right? If you don't have a quality gate process that says that the product is ready for operations by, our security team, by our test teams, by whoever, then a lot of times it's going to be really tempting, especially for marketing departments, to just throw it over the wall and start running it, right? And so when you do that, a lot of design considerations just get lost, and you don't have any way of verifying that things were done right to begin with, right? Is the telemetry being sent at all? Can we actually process it? Don't know, right? Have we done static analysis of anything? Do we have some tool like code coverage or any other sort of tool that can verify that we don't have simple buffer overflows? Have we done basic pen testing? What happens if I log in with a different user ID and an invalid password, right? Those kinds of things, right? And so those are the things that should be done in a quality gate process, and without them, you really lack the sword of Damocles, right? Your product teams, your development teams, they're just going to want to say, well, it works on my machine, I'm done. And as a developer, I've been guilty of this too, right? And it's just the way of the world. And you have to have the ability to say, no, you're not done until I say you're done, right? Until the security team signs off, until the performance team signs off. And I realize it sounds like a lot of work, but that is how you get a secure service. Now, 2 capabilities that most deployment pipelines do not have are the abilities to do stage deployments and fast rollbacks. First, let's define what they are. Stage deployment is the number of users who get a change. So you start with a small number of users. Maybe it's just your internal users, right? You get just a developer. That's stage 1, right? Stage 2 is a developer and that developer's local team. Stage 3 is your entire company. Stage 4 is some sort of insiders program, right? And you just keep adding more and more and more people in these concentric rings of circles, right? That is a stage deployment process. Fast rollback is the ability to turn a change off in any or all of the rings simultaneously, right? And to do it as quickly as possible. 1 line of code going in, should be able to come back out, and should be able to do so in real time, or very close to real time. We're talking, minutes, not hours, not days, not weeks. So, an early stage organization will probably have fast rollback because there's just 1 server and you can just change it whenever you want, but they probably won't have stage deployment. A response capable organization may actually lose fast rollback because now you've got, staging servers and things like that are in the way, and it actually gets harder to do fast rollback, and they may not even have thought of stage deployment. So this is the one time where you're better off at nothing than you are in the response capability, even though overall you're better off in response capability. And you're best off at continuous improvement because now you've defined official policies that make fast rollback possible and stage deployment possible, and you have the infrastructure and personnel needed to support that, right? And that is a sort of a difference. Some of the telltale signs that you're in a security context, in which organization you're in, is If you have nothing, then you know it, right? You have no RBACs, you have no access controls, you have no single sources of truth, and you have no telemetry. If you're in a response capability organization, then you have a telemetry system and you're able to use it and do responses of some sort. Maybe you can turn off a server or something like that. But it's a lot of it is ad hoc and incident driven, right? There is no formal process for doing something like threat modeling, right? It's not routine and normal part of your business. There is no sort of Damocles that your security team can use to say, thou shalt be secure or thou shalt not ship, right? And so you can see that kind of thing. And there is no concept of, well, let's test a security change on a small number of users and then grow the circle out until all of our users are secured, right? Whereas if you're in a continuous improvement organization, you'll probably have a data science team that will be part of your security team. They'll be able to do experiments and you'll be able to do these stage deployments. There will be a quality gate process. You'll have some influence over developers and can stop a bad security feature from shipping. All right. Now, the real McCoy here, right? He was one of my favorite characters in Star Trek. I really, really, really liked Bones, even in the remakes. Anyway, sorry, that's a little aside there. All right, let's talk about operations. This entire thing is probably the bulk of service lifetime, right? If it takes you 2 years to build your service, it'll take you 20 years of operating the thing. So, and I might mean that quite literally, right? So the bulk of your lifetime is going to be spent in operations of the service, and that's where the bulk of your incident responses are going to be. So let's look at how we're going to do this, right? So let's start with telemetry. So previously, I'm just going to scroll back here, we went and defined what the telemetry should be, right? We defined the functional telemetry and the trace logs. We built real-time pipelines and things like that. And now here, we're actually going to use them. Real-time, again, will be used for building alerts. An alert should beget responses. And the controversial claim I'm going to make is that responses should be automated. You can roll them back. You can stage deploy them. But if your alerts are good and your response automations are good, your security operations personnel will be a lot happier, and your service will be it'll be better secured. It'll be secured in real time, and you'll be able to use information from one service to secure another. So that is what you use that real-time telemetry for. Now, one of the problems that you're going to have is that you defined your functional real-time telemetry, right? I'm going to keep my blue here, this one, early in the design phase. But security is an adversarial model. Your hackers don't care about your design. They'll try and find and exploit you. According to the Verizon breach report in 2018, the average amount of time it takes for a security breach to be detected, just detected at all, is 6 months. And that's because they don't even have to hide. Most of the time, the information to detect what the hacker is doing is just not in your SIM, your security incident or event manager at all. It's not in any log file, right? And it's usually accidentally discovered, right? Someone is wondering why a server is slow and they're seeing the X just then, right? Or some security researcher contacts you because they found, your records on the darknet somewhere, right? And that is probably the worst way to learn about it. You have to, earlier we defined that you have a separate telemetry update process. So I'm just going to scroll to it right over here. This is why you have that process, so that you can make your alerts better over time, so that you can have the information needed to make your alerts better over time, right? Now, let's talk about your analytics. Your analytics telemetry, you should have information that lets you determine how well your security response processes are working. How many credential stuffing attacks have we discovered? Has that changed over time, right? Of the percent sessions that we've sampled, what percentage of those were attempted hacking attempts, and how is that changing over time, right? So you should also have security analytics as part of your analytics process, right? Now, the next thing I'm going to talk about here is this cold store. So, one of the core problems that I tend to see in security organizations and in general is an all or nothing approach to data storage and retention. There's a single data lake and everything's in there, or a single Hadoop cluster, or a single whatever, and there's 30 days of retention on that single whatever, and once that 30 days is done, sayonara. Well, remember what we said earlier, that security incidents are and breaches tend to be super long-lived. 6 months is the average time to detection. So you're going to need to have a very long data storage policy if you really want to be effective. Problem is that's expensive, right? So to mitigate that, what you can do is you can sample down. So you can say, ideally I'm going to have, 30 days of full information available in our data lake. And then the next 30 days, right, a month later, I'm going to take 50% of those and store those for another month in tape. Then I'm going to take 50% of that and store that, or something like that until you get down to a reasonable amount that's stored for a very long period of time, 2 or 3 years. This is to give your engineers a chance to find when and where a security bug or attack began, and so that you can actually identify what was taken and notify customers and do the appropriate things to fix the problem, right? So really think strongly about a cold store and really think strongly about how you're going to downsample from inbound telemetry down to a super long storage time, even if it's a very small number of records. All right, now the whole point of having telemetry is so that you can build models, right? This is where your data science team and your cybersecurity engineers come in. You should invest in building a sandbox infrastructure that closely mimics your real infrastructure, right? Every product, every service, as close as possible inside the sandbox. And this sandbox is where, now you can do this really cheap, right? You can literally do it on a couple servers, so it's not as big as you might think it is, right? And the sandbox is where your cybersecurity engineers can go and they can play back an attack. So they can say, hey, we had this attack, it didn't succeed, but let's play it back and see what the original attacker was trying to do. And here's how our services detected it, right? More worrisome is if you have an incident or a breach, being able to play back the how of it is going to be very important to figure out how to fix it. You should also be able to simulate things, an attack, one that you may not even know about. You may have read a paper, there might be a bulletin on something, you might see it in NIST, whatever, and so you can also play with attacks. It's not pen testing, right? It's not doing reconnaissance on your live site and trying to follow the kill chain and with real people. It is a simulation. Well, here's what this hacking tool would have done in this case, right? You should also be able to model your fixes, right? And your fixes are, I'm going to make a change to a service, and what's that going to do? If I dehydrate the service, will I break another one? Don't know, right? Will I cause a network outage if I, black hole an IP? Don't know, right? And this is where you can try out some of those simulations, right? So lastly is exploratory models, right? Exploratory models are things that are not preordained kind of things, right? I'm going to try applying a patch, and I want to see what happens to my service when a patch is applied, or what changes in telemetry if I make this change, right? And or even things like, well, how can I model better alerts, right? To find a way to detect different kinds of attacks or newer kinds of attacks. So that is purely exploratory analysis. That is what this is over here, right? Oh, sorry. Let's see if I have my pen back. That is over there. Now, this is sort of the next big stage, and that is containment. Containment is the process of stopping an attack or reducing its damage for a small period of time, right? There's a few different ways to do it: lockouts, throttles, challenge response kind of things, and API proxies. Let's go start with lockouts because those are the most obvious to talk about, right? So one of the temptations that's always there in any sort of containment is to lock an IP, is to just say this IP address or this server is not allowed to access anything. The problem with that is that might be a server. Do you remember back here we had the sandwich service, right? Service B. Well, its caller is service A. if you lock out service A, you will lock out a lot of different things, right? And so it's important to have a critical infrastructure do not block list, right? So that you know yourself, don't 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 lock out this IP. Now, another useful lockout is a cross-service lockout, right? So let's say that you detect a hacking attempt on one service, right? Your login service is a great example. So credential stuffing is a really common attack. Well, during the point where you first detect and stop detecting the credential stuffing attack, you should probably not allow that IP specifically to access anything that could be sensitive, right? So no billing information for something that looks like it might have recently had a credential stuffing attack, right? So let's go on and talk about other lockouts. So user lockouts. So that is an individual user is no longer allowed to access your service, right? That is actually a change in authorization, not in authentication. You don't know why they're not allowed. Now, it could be because you think their password is compromised, in which case the the deauthorization of the user will require a remediation action of the user changes password, right, or something like that, especially if the user is an employee. Or it could be some other reason. They left the company, or it's just a user that's got suspicious activity based on your data science models. Uh, Device lockouts are another possibility, especially if you're in control of the device, right? Or retail cash registers, this particular retail cash register is sending unusual requests or requesting data it shouldn't be, well, we can lock that device out, right? Another specific thing could be network lockouts. Our users can access any data they want as long as they're, not in India or in China because we don't have a presence there, right? And so we presume that anyone attacking it in those networks may be a hacker, right? All right. Now your lockouts themselves, especially if they're going to be automated, they're going to need, first of all, the exploratory and fixed modeling, right? And second of all, you need to be able to stage the deployment of them, right? So maybe instead of locking out being hard, you're either in or you're out, you do a percent time lockout or a percent session or a percent request lockout, right? Depending on how your service is designed. So maybe you say, 1% of the sessions we're going to just reject, then 2, then 3. And you have some sort of ramp up curve for how you're going to lock the person out over time. This gives you a chance to detect that you've locked out something that you weren't supposed to, that you locked out critical infrastructure but did not know that you had done so, right? The other thing it gives you a chance to do, and because you've staged your deployment in this kind of lockout, you can then fast roll it back. Hey, I've locked out the VPN server for all of China. Okay, well then let's not block that IP, right? Now, lockouts in any of these containment actions, they should be treated like code. So who installed a lockout? Why did they install a lockout? If someone detects the lockout is wrong, who removed it? Why did they remove it? This way, when you're doing your incident, your final post-mortem analysis of the incident, you have a chance to figure out what your processes would or should have been, right? It gives you a chance to see and find gaps in optimal process versus the process you followed for this particular incident or this particular containment policy. Okay. And that's only possible if you have commit history, and that's why that's in there. And lastly, API proxies. I'm a huge fan of this. In fact, this is the thing that I'm working on writing right now with ThinkPredict. So if you want to try one, go ahead and contact me. I'd be happy to talk with you about it. API proxies allow you to update a process, telemetry, whatever's being sent over the wire, your authentication, even your encryption, and do so without having to change code in your service itself. This is important for older services where you may not have the capability of changing the code anymore. Maybe you got the code from a vendor and maybe the thing is a pure binary, right? And you have no way whatsoever of cracking open the binary and changing its internal behavior. Well, you can proxy it. And when you do so, then you can say, okay, the request response cycle is going to now start sending data to the SIM, so you can start adding telemetry in the back end, right? You can say, well, this particular service is returning too much data, and no previous service needs it. It was just because the developer did a select star in SQL and just returned everything. Really common, by the way. So maybe we can author a dehydration policy and say, hey, don't return everything, just return, the user's first name. You can change AAA, right? So maybe you're using LDAP and you actually want to change your source of truth from LDAP to OpenID Connect or something like that. Well, you can do that here. And you can even re-encrypt data on the fly, right? So you can say, well, I'll give the user a bit of JavaScript and a decryption key, and their decryption key will come through some other channel. I'll email it to them, whatever. It's a bad idea, but you get it, right? And then and then the data will be encrypted in real time from the service from now on, right? You'll have to do some layer 3 work as well as layer 7 work to make it work, right? But that's just network configuration. And it's a good way to patch something that you can't easily otherwise change. All right. Now, if you have a service, you should have a way of correcting it long term, right? This is essentially the loop part of the SDLC where you go back and make changes and corrections. And you saw me scroll back a few times, right? And there's two different time frames of corrections you're going to have to make to your service, right? There's the short term. You're either in an incident right now and you need to make a change to the service itself, right? Or very near so. And then there's long term. That is, there's enough time, your containments are effective, they're working. You have some time, a week, 2 weeks, a month, to go in and put this into a bug tracker and track it as a security incident or something like that, right? In the short term, you should have a library that's pre-written and ready to go that can just be a simple REST call or simple API entry into your service, right? Require fixlib, right? And fixlib foo should be as simple as that, right? Or a PowerPoint presentation. Well, here's how you re-encrypt this, or here's how you validate the TLS tunnel, or something like that. That is essentially training. And this is your Developer Operational Response Kit, your DORK. I love the acronym, by the way. So maybe the quickest, and one of the things that I put in here is your telemetry standard will always evolve and change, and your quick fix thing, your response kit, and your libraries should always be up to the current standard. That way, any other tools that you have, alerts, whatever, will just start working with when this short-term fix goes in. You'll also need an emergency update process, right? So if you have a service that needs a change right now because there's an active hack going on or something like that, denial of service attack, whatever, right? And you need to make code change to do that. There should, in some database somewhere, an Excel spreadsheet, whatever, be a named responsibility on your security team that your developers can look up for how do I get through this emergency update process, right? How do we make a change, stage it to understand, how the change affects customers, and roll it back if necessary? And how do we do that in real time? Who can guide me through the process, right? You should also go the other way, and that is for tool X, this developer and this backup or this lead or this manager or whoever is responsible for figuring out how to get a change made into the system. Or in some cases, your security personnel should just be allowed to make the change themselves. And then that change can be reviewed and corrected as part of a longer term process, right? That really depends on your security maturity lifecycle and on the capabilities of your security team. All right. Now comes the last but not least. I'll pick another color here. Let's pick cyan, because why not? We'll use a darker one because I like it. Decommissioning. So data tends to live forever, right? I'm sure, especially in large organizations, there are databases and other information stores, SharePoints, whatever, that have potentially valuable information for long periods of time, even though that product or service is no longer in use. It is dead. It is decommed. And it's silently decommed, right? It just sort of fell off the usage radar. No one really cared about it anymore. People sort of forgot about it. This is especially true for microservices, right? And this is something that your SIM will actually know. If your telemetry was well defined and you had a trace log that said something like, function foo starting up in product bar, then you can actually say, hey, what changed over the last 6 months? What stopped coming? What did I have 6 months ago that I don't have now? Oh, I don't have bar anymore. It's silently decommed. Delete the data or put it into a retention pool of some sort that is harder to get at. Offline storage is great. Tapes, right? And that is a retention thing because hackers cannot steal that which they cannot access. And network access is the easiest access to get. So if you can de-network something, you may have a compliance or legal reason that you need to store the information, but that doesn't mean you have to keep it online and live, right? When you decom your data, also take a look and review your security groups. It's a great time to do it. Uh, those security groups are essentially a target list for hackers, right? They tell the hacker who has access to this important information, who may accidentally have a copy on their own machine or server, right? You don't want to leave a target list laying around in your infrastructure if you can avoid it, right? So decom the security group itself or demember it or however you're going to turn it off, right? If you've got RBAC, you should make the RBAC deny all on this point, right? Um, let's talk about your containers and services. That's the last thing, right? These services had physical embodiments somewhere. They were in a Docker container, which was, on a server somewhere in Amazon's cloud or Microsoft's or whatever, and you're gonna have to shut it down and make sure that you actually, shut it down, turn it off, archive its state. Here's the archive of the OS and everything else, so that should you discover a future need, maybe it was accidentally decommed, you can reactivate it as necessary by restoring the data live, restoring the security groups, and putting the data back onto a container, remapping your API if necessary, and then restarting everything. And that, is essentially the philosophy, I think, of my philosophy anyway, of how to design and secure services and microservices in the modern era with a SIM and additional security practices in place. Thanks so much. It was nice talking to you, and feel free to contact me. If you like this, go ahead and do whatever is right on the platform you're viewing it on, like, subscribe, whatever is that kind of thing. And if you're interested in an API proxy, feel free to contact me. I've got a beta. I'd love to work with people and see what that looks like for you. Thanks so much.